Okay, so again, A is just a constant. So can anyone see how to factor anything in this problem? Wesley's in. You call your name, you get 2 points. Wesley, Isaac, Olivia, Austin, Luke, Emmeline, Eli, Kira, Michael, Luke again, Kira. What do you think?
You could. Okay, this is way out there, but what are they called when you like the logarithms? Is that what they're called?
Oh, I'll give you 2 points for good thinking. We don't really use logs in this case.
Okay.
That's okay. Any way to factor this? Anyone?
Can you do like x minus a, x plus a on the top, like difference of squares?
Huh? Yeah, like what's the square root of x to the 4th, Emmeline?
2?
X squared.
Well, x squared, yeah.
Yeah, because x squared times x squared would be x to the 4th. So the top's going to be x squared. And Emmeline, what's the square root of a to the 4th?
A squared.
Good. And then we just write what's known as the conjugate, like this. Questions from anyone? And the whole idea is to find factors that match. So we have, like, we don't want to do anything with the bottom because we already have a matching factor. So we just think of them as being separate factors, and we get our very helpful yellow box. If you would like to be on the wall, feel free to come up with a nice, clever way to emphasize the yellow box. And you can we'll put your name on the wall for the next, I don't know, 12 years. See how long I last. Questions? Please.
So for the bottom, you just factored out 1.
All I really did, yeah, 1 is always a factor. So what I'm noticing is 2 for Jenna. When I have one fraction times another, and I do this all the time, it's just top times top, bottom times bottom. So this is definitely the same. Like this green box is exactly the same thing as this green box. No difference at all, just written in a different way. Questions? So why did I do it? Like, why did I go from the little green box to a big green box? Hands up. That's the reason. That's another key to this class, is the more you can understand the reason for something, the better you can apply it to some new problem. What's the reason? Got about half of you. Hand is raised, give yourself 2. We'll try Isaac.
Because it's easier to see that the right half can just equal 1.
Yeah, it's all about the yellow box. 2 more for Isaac. The yellow box is equal to 1. There are a couple of exceptions where the yellow box is undefined. Hands up. Who knows the exceptions when the yellow box is undefined? There we go. Like what value of x? Remember, a can't change. A is just 5. But x could be lots of different things. So what value of x will cause the yellow box to be undefined, Hope? If I put in as 2 for Hope, if I put in as 0 for x, I'm actually okay because I'll get a squared divided by a squared, which is still 1. So that's okay. But we're looking for a value of x that will cause the yellow box to be undefined. So many this time, Olivia?
I was going to say that there isn't any, or is, well, because I was going to say 0, but.
Oh, so I actually didn't notice. You're actually correct. There is nothing. Because if I plug in, like say negative a squared is going to be positive a squared.
Yeah.
So that won't be 0. If I plug in a, I'm going to get positive. So yeah, this yellow box is always 1. There's no exceptions in this case. Question? Sweet. But that's super helpful because this is 1. So now we just focus on this part here, the orange box. So when I plug in a number that is close to a, I get a squared minus a. So this is going to get really close to 0, the orange box. Really close to 0 multiplied by 1 is really close to 0. That's a bit of a trap also because a lot of students will think the answer can't be 0. And that's the answer, so please.
Would you be able to just plug in A to the like first big box and then just kind of like simplify from there?
Let's talk about that. That's, to be fair, is another trap to try to get you to step in. So Luke, if you plug a 0 into the, let's change color so the video can see what I'm talking about. If I plug a 0 into the blue box, what do you get for the top, Luke? Sorry, plug an 8 is what you did, right?
Yeah.
Yeah, if you plug A into the blue box, what do you get on the top?
0.
You would, so you gotta be careful because you're really not plugging in A. You're supposed to be thinking that you're plugging in close to A, which means the top will be close to 0, like maybe, I don't know, here's close to 0. Comfortable with that?
Yeah.
If you plug an A into the bottom, or close to A, this one works out just fine from the beginning, you're right. Factoring wasn't even needed. It's not common that happens, but this one did work that way. Because if I plug in close to A here, the bottom's like 2A squared, but close to 0 divided by whatever is still close to 0. Yeah, 2 more for that, that's well done. Often it won't work. Often what will happen is this, Luke. You'll get the bottom close to 0 also, like say something like this, and then you don't really know what you have, because this actually turns out to be 1 over 100, or worse, if the bottom is something like this, it ends up being 10. So you can't really predict it. In fact, I will tell people all the time that if you're doing a limit and you end up with 0 divided by 0, you forgot to factor most likely. So, other questions? Please.
So what are the rules with A? Like what are the rules with A? Like what is something we should always remember with the variable A?
So it's not a variable, it's a constant, meaning that for the purposes of the problem, it is simply taking the place of a single number. You just don't know what the number is. So the number could be 5, could be 8, but it's just going to be one of those. Whereas x is really a list of numbers from negative infinity to positive infinity. 2 for Jessica. Do it on your own, please. Raise your hand if you can tell me what the right half horizontal asymptote is for this problem. Go do it yourself. That's part of the yellow is to find the asymptotes. So find the right half horizontal asymptote, which means you're finding the limit as x approaches positive infinity. I'll walk through them. Stop me if you're not sure what to do. Raise your hand if you have this either written on your paper, or you can honestly say you got that far just mentally without writing anything down. Boys? Questions about how to get there? The rest of you didn't get there. Just summarizing for the video, since x is approaching infinity, I'm going to compare terms that add. So this is going to get very large as x becomes more and more positive. This, because a is a fixed value, won't change at all. It's just whatever it is. So something that gets larger and larger and larger added to a fixed value, the x to the fourth will dominate between those two terms. A similar idea with x squared in the bottom. Question? Luke?
It's kind of like another shortcut. I don't know
Yeah.
if you should be doing these, but since it's a power function and the degree of the numerator is higher than the degree of the denominator when the automatically.
Yeah. So this what's happening is as x. So what's the limit here, Luke?
For what?
So what's the limit?
Oh, that there's infinity.
So that means as x approaches, two more for Luke. The shortcut is totally valid as long as you're just dealing with power functions that are being added. So there is no horizontal asymptote to the right. And another shortcut is because they're power functions, I'm going to get to this same place if x were approaching negative infinity. So I'm going to get the exact same result because this is being squared. So this would be like, plus or minus, you get the same thing. So the horizontal asymptote, there is none. Question? For Luke. Please.
Sorry, because
No.
when it's just like the f of x equals 8, how come that's an asymptote, but then this wouldn't be an asymptote? It's like the asymptote is just the end behavior.
Oh, I said that badly. It's in behavior as long as you're still either approaching or equaling a fixed value.
Okay.
In this case, because the y-coordinate continues to grow forever, that's not, I use a dumb word, I say it's not horizontaling, it's climbing. Does that make sense?
Yeah.
Two more, please.
So the reason is there's no vertical asymptote is because when you plug in negative infinity, you're not getting the same answer.
I said that badly, T. for Austin. If I do this to negative infinity, the comparison rules for power functions are exactly the same. So I still get this line. And then when I break up the factors, I'm still going to get this line. So if x is very, very negative, this is still going to equal 1. But a negative squared is going to be a positive. That's why it doesn't matter if x is going to positive infinity or negative. Either way, the y-coordinate's going to grow. Like I'm going to end up with a graph that I don't know what the graph looks like, but I know on this end I'm growing, and I know on this end I'm growing. I don't know what's happening in between. That help.
Yeah, and then for the actual answer being infinity, would that be x squared and x squared pretty much equaling 1, and then x squared over 1 being infinity?
Correct. Like you're thinking, okay, so if I plug in a large x,
Yeah.
this is exactly 1. That large x squared is going to just keep getting bigger and bigger as x gets bigger and bigger.
Right.
That's what causes the value of the limit to be infinite. Or you can say it's non-existent. They'll accept either answer. Two more for Austin. Cool. Stop that video.